Welcome back, dear children. This is the problem that we are going to discuss. Just before that, let's see something very important and interesting. Here we have a triangle, a right angle at this point. And A and B are the length of the smaller sides or orthogonal sides or perpendicular sides. And the C is the length of the hypotenuse. Here, the interesting fact is that if we find the sum of these two areas, that means here we have a semicircle with this side B as its diameter, and this is a semicircle with A as its diameter, and this is a semicircle with C, the hypotenuse C as its diameter. And here we can see that the sum of these two areas, that is this 7 plus 2, it is equal to 9. Okay, here this is not only true for these semicircles, it's true for all regular polygons. If you draw a triangle, equilateral triangle here, along with the sides of this triangle, we can see that 7 plus 3 is equal to 10. And if we increase the number of sides from 3 to 4, we will get squares along with the sides of this triangle. So here, this is B square, 17, A square, this is 6, and C square is equal to 23. And this is what Bauduin said, or Pythagoras said long before. That is, A square plus B square is equal to C square. Okay, this is not only true for the squares. If we increase the sides like this, we will get the sum of these two areas is equal to the area of the polygon drawn along with the side hypotenuse of this triangle. Okay, this is very interesting. And here this applet is embedded here just below the video, and you just go to the site pradeshmaths.in, and just below the video you will get all these applets. Just reach here and change these values and feel it yourself. Okay, so let's go back to our problem. In this problem is given that you are given a triangle. Here is a right angle triangle, but it's not mentioned in the question. Why? Here the question is given that you have to draw a semicircle, choose a point on the semicircle and connect that point with the ends of this diameter, and you will get a triangle. Obviously that will be a right angle triangle at this point, because we know that angle in a semicircle is right, therefore this is a right angle triangle. It need not mention here in the question, but it's a right angle triangle, it's understood. Okay, and here let's move back to that point. Here this figure is obtained by folding like this. Actually this proof contains two parts. The first one is to show that the sum of the areas of this blue semicircular region and this semicircular region equal to the area of this bigger green semicircular region. And by using that, we have to show that the sum of the areas of this blue crescent and this red crescent equal to the area of this yellow triangle. Okay, here what we have seen here, sum of the areas of these semicircles is equal to area of this semicircle. Okay, so we can see that this A, B and C are the sides of the triangle. Then A square plus B square is equal to C square. As Bauduin said, sum of the, in a right angle triangle, sum of the squares of the smaller sides or orthogonal sides is equal to the square of the hypotenuse. That is Bauduin said or Pythagoras said long before. It is how we have to pronounce Pythagoras, not Pythagoras. It's Pythagoras. Okay. Here, area of this semicircle is 4, that of this semicircle is 14, and the area of this green semicircle is 18. That means sum of these two areas is equal to area of this one. Okay. So this is what Pythagoras said long before, that is A square plus B square is equal to C square. So here, area of this semicircle with BC as diameter. This BC, what is the length of BC? Is A. Then what is the radius of this semicircle? If the diameter is A, the diameter of this semicircle is A, then what is the radius? Radius is the half of A, that is A by 2 is the radius of that semicircle. Then what's the formula for finding the area of a circle like this? If the radius is R, what's the formula for finding the area of this circle? We know that it is pi r square. We want only the half of that. Therefore, area is equal to half of pi into a by 2 square. Here, r is the half of a. Therefore, pi. This half is for making semicircle, and pi is the r is a by 2. Therefore, half of pi a by 2 square is the area of the semicircle. Okay. Then when we distribute this square to the numerator and denominator, we will get half of pi into a square. Square will be given to both numerator and numerator. Therefore, here a square divided by square of 4. Square of 2 is equal to 4. So here we will get, simplifying, we will get 2 into 4 is equal to 8. Therefore, it is equal to pi into a square divided by 8. Here, area of the semicircle with BC as diameter. That means if the diameter is a, its area is pi into a square by 8. Okay, listen. If the diameter is a, its area is pi into a square by 8. Then what would be the area of this one? With the diameter b. If the diameter a is pi into a square by 8. If the diameter is b, then what would be the area of this? What would be the area of that blue one? It would be pi into, instead of a square, we will have to use b square. Pi into b square by 8. Therefore, area of this is pi into b square by 8. In the same way here, if the diameter is c, instead of b square and a square, we will have to use c square. Therefore, it is equal to pi into c square by 8 is the area of this one. Here, we have to show that sum of these two is equal to pi into c square by 8. For that, here area of the sum of these two, this blue one and red one is equal to pi into a square by 8 plus pi into b square by 8. We have to find the sum of these two areas. So, pi by 8 is a common factor in both of these terms. Pi by 8 is here in both of these terms. Therefore, we can take that common factor outside. Then, if we pull out this pi by 8 from both of these terms here, what would remain here? This a square, and the second term b square will be the, therefore, pi by 8 is common factors taken out. Therefore, a square plus b square would be there in the bracket, inside the bracket. Therefore, what we know that a square plus b square in this hypotenuse, in this right angle triangle, what would be the sum of the squares of these two sides? A square plus b square is equal to c square, that we know. Therefore, substituting c square in the place of a square plus b square, we would get the sum of these two areas is equal to pi by 8 into c square. That is, pi by 8 into c square is the sum of these two areas. Okay, this is the first stage of our proof. That is the area of the green semicircle. Okay, so what we have proved here, the sum of the areas of this blue and the red semicircles is equal to area of this green semicircle. Okay, so let's move on to the second stage. By flipping or folding it, we will get the required figure as in your textbook. So here, what we have to prove? You are asked to prove that the sum of the areas of these crescents, that is, this blue and red crescents, is equal to area of this yellow triangle. Here, in your question, it is asked that to prove the area, sum of these two areas, the sum of this blue one and this red one is equal to the area of the yellow triangle. That's what we have to show. Let us represent the area of this triangle by the letter P. P is the area of this triangle. And the area of this region, this green region, is Q, and the area of this green region is R, and the area of this crescent, this blue crescent, is represented by X, and this crescent is of area Y. Now what we have to prove here? Here we have to prove that the sum of these two areas is equal to area of the yellow triangle. That means X plus Y is equal to P. That is what we have to show. Here we have to show that X plus Y is equal to P. This is what we have to show. We have to keep it in mind. Only then our brain will work towards the final result. So here X plus Y is equal to P. That is what we have to show. And we know that, but we know that sum of areas of these two is equal to area of this green one. For that, see here, if we fold, what is the area of this semicircle? That is, X plus Q is the area of the semicircle, blue semicircle. Here, this is the blue semicircle, and the total area is split into two parts. That is, X plus Q is the area of the semicircle, and here in this semicircle, here the area of the semicircle is equal to Y plus R. Here Y plus R is the area of the semicircle. Then what is the area of this green semicircle? The green semicircle, these three regions are coming inside this semicircle. Therefore, the area of this green semicircle is obtained by adding this P, Q and R. Therefore, we can write, we know that, what we know, that here the sum of these two semicircles, that's green one, blue one and red one is equal to this big green semicircle. We know that the sum of these two areas is equal to area of this one. We know that the sum of these two is equal to this. We have already proved that. So here, what is the area of this blue one? That is x plus q is the area of this one. Then y plus r is the area of this red one. And what is the area of this green one? P plus q plus r is the area of this green one. So we have an equation here in which two terms are common on both sides. Here, this side we have q and r, and this side on the right hand side also we have q and r. Cancelling out these two common terms from both sides, we will get. We can avoid this q and r from both sides, or we can cancel out these q and r from both sides. What would remain here? X and y. Therefore, x plus y would be there on the left hand side, and on the right hand side only p will be there. Therefore, x plus y is equal to p. That's what we have to show. Here, what is x plus y? X plus y is the sum of this blue, this blue and red crescent, and p is the area of this yellow triangle. Therefore, sum of the areas of blue and red crescents equal to the area of this yellow triangle. Okay, I think this proof is very clear to you, but it's very simple. And I have embedded these applets, all these three applets, Malayalam medium, English medium and this other one, just below the video in pradeshmaths.in. You have to go to here, you will get two fields here. This is search field and this is the address field. Therefore, you need not write here because I am not so popular. That site is not so popular. You would not get it by typing here. You have to type directly here pradeshmaths.in. Then if you type pradeshmaths.in here in the address field directly, you will get this site and go to this 10th circles. Then just move up. Then you will get this here. Then just below that video, you will get applet 1. That is the applet I embedded or used here. Here a three-dimensional aspect is there, three-dimensional window is there. Therefore, it will take some time to load. Graphics will take some time to load. But wait, and after loading it, it will work wonderfully. So here, when you press, you can check the software as we did here. Okay, so you can feel this mathematics yourself. Okay, you can write note by the help of this. And just below that, embedded another method of solving this. Okay, you go through that if it is interesting. It is there. It would be a wonderful experience for you, no doubt. Okay, make use of it. See you in the next video.